Welcome. In this segment, we'll talk about image interpretations. And this is the first video of this topic. And in this topic, we'll talk about two different tools. One is the spectral mixture analysis, and then the other one is the image time series analysis. And let's get right to the script. In this first example, as I mentioned, spectral mixture analysis is what you are seeing on screen there. And we first begin by using starts from line 7. That is where this example starts. And on line 7 to 11, as what I'm highlighting there in the script, this is where we are importing a Landsat 5 image, and we're displaying it to our map. And this should not be new by any means at this point. So then, let me just give you some very brief background to what spectral mixture analysis is. So spectral mixture analysis is simply when you are looking at satellite images by each pixel, looking at how much percentage of a component that you are looking at is in that pixel. So this obviously, so for example, if we're trying to look at an image that has a lot of water inside of it, and we extract the pixel outside of that image, so we pick that pixel out, for example, and we're only looking at this pixel, we can be able to use this spectral mixture analysis to see how much percentage of water is inside of that pixel. And oftentimes we don't get pure pixels, obviously. We will get, for example, pixels of water mixed with trees or vegetations. We'll have pixels that will mix sometime buildings, maybe that is pure, that could be cement, just purely rock minerals. And we can also get pixels that comes in different sizes and shapes. So in order to interpret it, what percentage of an element that is inside of that pixel you're looking at, we need very, very pure measurement of the reflectance of an element. For example, water or some other elements such as any other chemical element. And by using those measured pure reflectance of pure element, we can implement these reflectance into our analysis to give us the percentage of those elements inside of a pixel we're looking at. So let me just use an example so I can better explain instead of just using my hands here. On line 14 is what I mentioned earlier. So there has been measurements made for a pixel that is defined as purely urban pixel. And these values you're looking at, so I'm just highlighting, it helps you better to see here on line 14. These are simply the reflectance values of an element that is inside a spectrometer. If you know that term, that is what oftentimes people use to measure these reflectance values. And the reason why there are 7 different values is simply because the Landsat image has 7 different bands, and we need a reflectance value for each of those bands in order for this to work. And similarly, we apply to vegetation pixels, vegetation reflectance on line 15, and also the water reflectance on line 16. And then we apply these reflectance values on line 19. This is where we use this function that is called onMix, as you can see on line 19 there. And this helps us to predict the percentage of the urban vegetation water that it is inside of individual pixels we are looking at inside the Landsat image. And I will show you what that looks like once we run this. So here, just in the notes, we can be able to just look at the bare fields in the west of Syracuse. What are the different elements that is inside one of those fields? And let's just run this, and we'll open up the map to show you what this spectral mixing analysis looks like. Okay, so immediately I will point you to how many layers this is. As you can see there are two different layers. The first is the image, which is the original Landsat image, as you are seeing there. And as you can see, this is a red. If it looks very red, is because I use the color infrared combination, and it is not the natural color, of course. And then the second layer we are turning on here is the unmixed layer. And as you can see, there are different colors associated with it. And as recalling, we have utilized, as if we can show here real quick, the three different types of elements: the urban, vegetation, and water. And when we are looking at the image in the map here, there are three distinctive colors that you are seeing from this map or this image that I'm displaying. One is the water, which you can see in the Onondaga Lake. It shows the blue color there. And the other you are seeing that stands out is the greenish color. And as you can see on the screen there. And so that is corresponding to the vegetation class. And the other color you might be seeing is this orangish color, as well, where my cursor is pointing at there. So it's kind of all over everywhere. And this is corresponding to the urban land cover mixture. And if we want to see the mixture of these three different classes, we can simply turn on the inspector tab on the top right, as you can see there. Once you turn on this inspector tab and you put your cursor onto the map, as you can see there, so I'm gonna just move my cursor to on top of the Onondaga Lake, so it's easier for you to see there. And if we click on the lake, so I just clicked on where my cursor looks at, and we scroll down the results of this, and we come up to this unmixed image band 0, 1, and 2. So as you can see, this is the percentage of the urban vegetation and water inside of that water pixel. And as we can see, the values shows up very distinctively. The water composition is almost 100%, which is this 1.00 number there. And that makes a lot of sense. And if we look at the different area, for example, the downtown of Syracuse. So if I put a random point somewhere downtown Syracuse, and we come back to this number, we'll be able to see that pixel inside of downtown Syracuse. Most likely I've clicked on a impervious surface of some sort. The percentage of urban land cover that we are interested in this example is 79%. And the water percentage is about 50%. And as you can see, this is a way for us to discern the different types of elements inside a pixel. But in order to use this, of course, we have to go out and measure the pure reflectance of every single thing on this planet or whatever you wanted to look at. So obviously you don't have to do that. USGS has created an entire database that you can look at for these reflectance values, so you can plug them into this spectral mixture analysis for further studies. So this is an example, simply just showing you what this mixture of spectral analysis is. So the next topic we'll talk about the image time series analysis. And let me just uncomment this so we can better see it. This example is a little bit more involved as I will go along here because we are printing a graph in the console area. But we'll get into the easy part first. As you can see on line 33 to 40, we are simply just constructing 3 different points in these different areas. So a point inside the city of Syracuse downtown, another point inside a park that is called the Clark Reservation. I will display in a moment, and also a point inside the Oneida Lake. And these 3 points help us to extract values of a band. And if you have multiple layers of a band or an image, you can be able to see how the value of that pixel changes over time. So if you look straight down a stack of images and you lay them down by the different time they were taken, you can be able to see how that value changes over time. And this is exactly what image time series analysis is for. So when we continue here, we just simply display these points on our map down below on line 42, as where my cursor is pointing at. Then just moving on to line 45 to 49, where I'm highlighting there, this is simply we are extracting a collection of images from Landsat 8 to for our analysis and to display the value. And here we restrict the images that was taken from 2013 to 2016 as what I'm highlighting there. We also select the band of B11 on line 48. And that is the band where it displays the thermal imaging, if you will, the thermal values of a point or a pixel inside of the Landsat image. And then we filter them by cloud cover, and we only need cloud cover that is less than 40, so it's going to give us a nice clear trend inside the image time series analysis. Then on 52 to 64, where I'm highlighting there, this gets a little bit more complicated since we are displaying a chart that displays the values of those 3 points that we are looking at inside of this image stack. And we display this chart inside the console area, which we will look at in a moment. And a few quick points I want to mention. First is the title, the axis label. As you can see there are different parameters that you can set for your chart to display better and make better sense. And the other point I want to mention is 61 to 63 is we label the lines inside of the chart by different colors, and we are representing different colors for different values that were extracted from the 3 points that we initially constructed. Then at the end, of course, on 67 is where we print this chart inside our console. So let's run that real quick. And we'll be looking at the map for one quick second. And as you can see there are 3 different sampling points. One is located inside the Oneida Lake. And then the other one is located inside the city of Syracuse. And the third one is located inside a park that is called Clark Reservation. And let's go to the console area to see our chart. So obviously this is not very clear at first. And there is an icon to the top right of this chart, as we can just simply blow it up to the page real quick. So when we just blow it up here on the screen, as you can see, it is showing you the different trends of the different points that were, the different values that were sampled at different points. And you can see the values, if I can just zoom in here. Okay. And you can see the graph shows the 3 distinctive lines, the red, and then you can see the green, and then you can see the blue lines. The blue line is associated with the values that were sampled in the lake, the Oneida Lake. And the green line is associated with the point that was located inside the park, and the red is the point that's located inside the city of Syracuse. And as you can see this zoomed in version on the screen, you're seeing there, it is very clear there is a distinctive pattern to this data, because it's showing the red one approach the peak much higher than the green one, and then the water, which is the blue one. And this makes a lot of sense, because what you are seeing is showing sort of this urban island effect of the impervious surface inside a urban area that has much higher temperature than a forest. And then the water obviously absorbs a lot of those energies. So it does not show a very high temperature as comparing to an impervious surface inside the city of Syracuse. And this is a very useful way to look at long-term trend of a particular feature that I'm looking at. So for example, if I wanted to look at how a vegetation is doing inside a pixel, we can simply just put a point on top of that pixel that is where the vegetation is located at. And we can sample the NDVI values, as we mentioned before, and we can interpolate that trend in order to explain if this vegetation is doing well or not. And the various different type of vegetation index that I've mentioned before, and also you can look up, is a very useful companion for this image time series analysis. And this example just shows you a very simple way to do this. And just going back to the script here, and just showing you the whole image time series sampling process only took 50, so from 52 to 64, just a few lines of code there. And comparing to traditional approaches that we do, for example, in other platforms, we have to download every single image and then drill down, and those take a lot of time. So in Google Earth Engine, it simply saves us the time and the space needed to store those image stacks. And the drilling can be done by Google through those images and extract the values and save a lot of computing powers through this approach. So there you have it. These are the two different tools that you can use. One is the image spectral mixture analysis, and the other is the image time series analysis. And in the next segment, we will be talking about the second video in image interpolation. And these includes the classifications and also the accuracy associated with the classifications. And hope to see you there. Thank you.